In the vast expanse of our solar system, where countless celestial bodies dance in the cosmic ballet, there lies a giant that commands attention. Jupiter stands as a giant, a colossal planet that dwarfs all others in our solar system. Its immense size and mass make it a dominant force, exerting a powerful gravitational pull that influences a myriad of celestial objects. This gravitational pull is not just a force to be reckoned with, it is a cosmic magnet, drawing in and holding captive a diverse collection of moons and other celestial bodies. These objects, each with their own unique characteristics, orbit Jupiter in a complex and fascinating dance. Among them are its moons, a diverse collection of worlds, each with its own story to tell. From the volcanic activity of Io to the icy crust of Europa, these moons offer a glimpse into the varied and dynamic nature of our solar system. In November 2000, a team of astronomers led by myself made an exciting discovery: a new moon orbiting Jupiter. This discovery was the result of countless hours of observation and analysis, a testament to the dedication and perseverance of our team. Initially designated as S2000J9, this celestial body would later be named Taygete, after a figure from Greek mythology. Taygete, one of the Pleiades, was a nymph who was transformed into a star, a fitting name for a moon that shines faintly in the night sky. The discovery of Taygete was not a solitary event. It was part of a larger effort to systematically search for and catalog Jupiter's numerous moons. This endeavor required the use of advanced technology and meticulous planning, as we scoured the skies for any sign of new celestial bodies. It was part of a larger effort to systematically search for and catalog Jupiter's numerous moons. Each discovery added a new piece to the puzzle, helping us to better understand the complex system of satellites that orbit this gas giant. Using powerful telescopes atop Mauna Kea in Hawaii, we scanned the region around Jupiter, looking for faint points of light that moved along with the gas giant. These telescopes, some of the most advanced in the world, allowed us to peer deep into space and uncover the secrets of the universe. Our efforts paid off with the identification of Taygete, adding another piece to the puzzle of Jupiter's complex system of satellites. This discovery was a significant milestone, providing us with new insights into the formation and evolution of Jupiter's moons. This newfound moon, though small and faint, captured our attention. Its discovery was a reminder of the vastness and complexity of our solar system, and the many mysteries that still await us. It became clear that Taygete was no ordinary moon. Its orbital characteristics hinted at a shared history with a group of other Jovian moons. This connection suggested that Taygete and its companions may have formed from the same primordial material, offering clues about the early history of our solar system. This realization sparked further intrigue, prompting us to delve deeper into Taygete's origins and its connection to the broader Jovian system. We began to study its orbit, composition, and other characteristics in greater detail, hoping to uncover more about this enigmatic moon. The discovery of Taygete, like many scientific breakthroughs, opened up more questions than answers. Each new piece of information led to new hypotheses and theories, driving us to continue our exploration and study of this fascinating moon. However, it provided us with a unique opportunity to study a distant world, to piece together its history, and to gain a deeper understanding of the processes that shaped our solar system. The journey of discovery is ongoing, and with each new finding, we come one step closer to unraveling the mysteries of the cosmos. Taygete's journey around Jupiter is a testament to the powerful forces at play in our vast solar system. Unlike our own moon, which orbits Earth in a relatively circular path, Taygete's orbit is far from ordinary and quite unique. It travels in a retrograde direction, meaning it circles Jupiter in the opposite direction to the planet's rotation. This peculiar characteristic is a key clue to Taygete's origins, suggesting a past shaped by gravitational capture rather than formation alongside Jupiter. Furthermore, Taygete's orbit is not a perfect circle but rather an ellipse, with a significant eccentricity. This means that its distance from Jupiter varies throughout its orbital period, which lasts approximately 691 Earth days. At its farthest point, Taygete is about 22.4 million kilometers from Jupiter, while at its closest, it ventures much closer to the gas giant. This elliptical and retrograde orbit places Taygete within a group of Jovian moons known as the Carme Group. These moons share similar orbital characteristics, suggesting a common origin and history. They are thought to be remnants of a larger celestial body that was captured and subsequently fragmented by Jupiter's immense gravity. Understanding Taygete's orbital dance is crucial to unraveling its complex history. By studying its path, we can glean insights into the gravitational forces that have sculpted its journey and connect it to other members of the Carme Group. In the vastness of space, where the boundaries of our solar system stretch into the unknown, there exists a fascinating collection of celestial bodies that orbit the giant planet Jupiter. Among these moons, Taygete is not alone in its journey around Jupiter. It is part of a larger family of moons that share a common bond. This family is known as the Carme Group, a fascinating collection of satellites that have intrigued astronomers for decades. The Carme Group is a collection of satellites that share a common origin and similar orbital characteristics, making them a unique subject of study in the field of planetary science. This group, named after its largest member, Carme, comprises over a dozen moons. Each of these moons is a small world with its own story to tell, contributing to the rich tapestry of our solar system. The Carme Group is characterized by their retrograde orbits, meaning they circle Jupiter in the opposite direction to the planet's rotation. This intriguing feature sets them apart from many other moons in the solar system. The retrograde orbits of the Carme Group suggest a fascinating history. These moons likely did not form alongside Jupiter, as the planet's original building blocks would have been rotating in the same direction. Instead, it is believed that the Carme Group originated from a single parent body that was captured by Jupiter's immense gravity. Over time, this parent body fragmented, possibly due to a collision with another celestial object. This shared trait of retrograde orbits and the story of their origin provide valuable insights into the dynamic processes that have shaped the moons of Jupiter. The Carme Group, with its unique characteristics, offers a glimpse into the past, revealing the complex interactions and events that have occurred in our solar system over billions of years. Taygete, with its retrograde orbit and similar distance from Jupiter, fits perfectly into the Carme Group. This association provides valuable context for understanding its formation and evolution. By studying Taygete and its fellow moons in the Carme Group, astronomers can piece together the history of these captured objects and learn more about the dynamic processes that have shaped Jupiter's moon system. The Carme Group serves as a reminder that our solar system is a dynamic and ever-changing place where celestial objects are constantly interacting and reshaping their surroundings. By studying these groups of moons, we gain a deeper appreciation for the complex dance of gravity and the interconnectedness of objects in our cosmic neighborhood. The Carme Group, with its unique characteristics and intriguing history, continues to captivate the minds of astronomers and space enthusiasts alike. As we delve deeper into the mysteries of these moons, we uncover new layers of understanding about the formation and evolution of our solar system. The study of the Carme Group not only sheds light on the past but also helps us predict the future dynamics of celestial bodies in our solar system. The Carme Group serves as a testament to the ever-changing nature of our cosmic environment, where forces of gravity and collisions continually shape and reshape the celestial landscape. By studying these groups of moons, we gain a deeper appreciation for the complex dance of gravity and the interconnectedness of objects in our cosmic neighborhood. The Carme Group, with its unique characteristics and intriguing history, continues to captivate the minds of astronomers and space enthusiasts alike. As we delve deeper into the mysteries of these moons, we uncover new layers of understanding about the formation and evolution of our solar system. The story of Taygete and the Carme Group is a tale of cosmic collisions and gravitational capture. It is a fascinating narrative that takes us back to the early days of our solar system, a time when chaos reigned supreme and celestial bodies frequently collided and interacted in dramatic ways. Astronomers believe that these moons were not born alongside Jupiter, as were the planet's inner moons, but instead originated from a captured object that met a cataclysmic end. This theory is supported by extensive observations and simulations that suggest a different origin story for these outer moons. The prevailing theory suggests that the Carme Group's parent body was a large asteroid or perhaps even a small moon from the outer solar system. This object, likely wandering through space, found itself on a collision course with Jupiter, the largest planet in our solar system. This object, drawn in by Jupiter's immense gravitational pull, ventured too close to the gas giant and was captured into its orbit. Jupiter's gravity is incredibly strong, capable of pulling in objects from great distances and altering their trajectories significantly. However, its journey did not end there. The captured object continued to orbit Jupiter, but its fate was sealed by the chaotic environment of the early solar system. It is thought that this captured object experienced a significant collision with another celestial body, perhaps another asteroid or comet. Such collisions were not uncommon in the early solar system, where countless objects were on intersecting paths. This impact, occurring at high speeds, would have shattered the parent body into numerous fragments. The energy released in such a collision would be immense, breaking the object into pieces that would then continue to orbit Jupiter. These fragments, still bound by Jupiter's gravity, settled into similar retrograde orbits, forming the Carme Group we observe today. Retrograde orbits are those in which the moons move in the opposite direction to Jupiter's rotation, a clue to their violent past. This violent history is supported by the Carme Group's shared orbital characteristics, particularly their retrograde motion, which is unusual for objects that formed alongside a planet. The retrograde motion indicates that these moons were likely captured rather than formed in place. Additionally, the moon's relatively small sizes and irregular shapes further suggest a fragmented origin. These characteristics are consistent with the idea that they are remnants of a larger body that was broken apart. The formation of the Carme Group provides a glimpse into the chaotic early days of our solar system, when collisions between celestial objects were commonplace. This period was marked by frequent and violent interactions that shaped the planets and moons we see today. By studying these groups of captured moons, we can piece together the history of our cosmic neighborhood and gain a deeper understanding of the processes that shaped the planetary systems we observe today. These studies not only reveal the past, but also help us predict the future dynamics of our solar system.